Hey guys, it's Casey from the Montreal Student Network, and today we're going to be talking about alkyl groups. Alkyl groups are an expansion off of what we looked at last video, which was the IUPAC or IUPAC naming for basic hydrocarbons. Alkyl group naming deals with, what happens when the group that branches off is a little bit more complicated than just a methyl group. Last video we just saw when we had a CH3 methyl group branching off, and that's simple. We know it's called a methyl group. But what happens if we have 3 carbons in that branch? How do we name it? Well, alkyl group naming is essentially the art of naming these branches. It takes some of the same concepts as we saw last video, but it does a little bit of a twist on them. So we're going to look at it. I'm going to take it very slow this video. We're just going to look at the main ideas of how it works, because there's just one basic pattern that you can follow through to name any alkyl group. So first off, we can look at exactly what is the name alkyl. We see how the word alkane indicates a hydrocarbon, only carbons, only hydrogens, that has only single bonds. Well, we're going to keep that knowledge in there, and we're going to just drop the ending of A-N-E and replace it with Y-L, because we're essentially going to take the names of stuff we had before, like butane, and we're going to get rid of the A-N-E and we're going to replace that with Y-L. So instead of butane, it would be butyl, and that would indicate it is a branching. Notice how methyl is actually somewhat of a derivative of methane, just as the way as propyl will be a derivative of propane and ethyl will be a derivative of ethane. It represents the branched version. So when you ever want to know what exactly the YL indicates for an alkyl group, you can always associate it with the ending that occurs with what we're going to be looking at in a second. You'll see down here I have a couple things prepared, propane and propyl. So first let's look at what we have right here, and we'll see how it's a little problem, how we can't just name it straight up. We need to know exactly what the color branch is. So first we have to associate with the longest carbon chain, and this is somewhat of a symmetrical structure, so we can count 1, 2, 3, 4, 5, 6, 7. It doesn't matter if you number it down here, you still get the same amount of carbons. And we notice that on carbon number 4 we have this big group over here. Now that's a bit more complicated than a methyl group, so we can't just use a nice simple name. We need to look at it and break it down and find out what it really is. And here's the bond line representation. I'm always going to keep both of them. I decided that it's a little bit easier for you guys to look at both condensed and bond lines, so I want to keep this as simple as possible. Just so you know, you can count 1 carbon, 2 carbon, and 3 carbon. Do not include this carbon in the branch. It's not included. That's a mistake I've seen a lot of people in my class make. These are the only carbons that are part of the group. They represent, this CH2 over here represents this carbon represents this, and finally the NCH3 represents that. I know that's a little bit of a mess, but that's essentially what's going on. So we can look at, what do we know? We know that when we have, because look, we have 3 carbons in that branch. We know when then we have CH3, CH2, CH3, 3 carbons. So let's just write 3 carbons. We know that the name associated with that standalone structure is propane. So propane is the name associated with 3 carbons. So since we have a branch and it's an alkyl group, we're going to just use that same concept we have. We're going to notice that it's a branch that only has carbons plus hydrogens, and it's only single bonds. So just looking at those 2 criteria, we know that it passes as an alkane, which we can easily convert to an alkyl group just by changing the name. So we notice how propane cut out that A-N-E ending and replace it with YL, and that's exactly how you can turn any single hydrocarbon alkane into a propyl. So when you want it to be acting as a branch and you want to name a bigger compound and you want to break it down, all you need to do is do this little thing right now. So look, if you wanted to look at something more complicated like hexane, would just simply be hexyl. And you just use it like we saw it with the methyl group last video. So let's go ahead and name the compound we saw above. It looks a little complicated, but all you really need to do is look it up. Here, I'm going to redraw it down here because I just scribbled all over it. It's a bit of a mess. So like that. And there we go. So we can do, we'll just do the whole process right now so you guys can follow along and do the proper naming process. So first we're going to identify the longest carbon chain and we're going to number it. Always number it. Numbering is not a waste of time. It will save you a lot of mistakes, and it's one thing I advise. I do think condensed formula is a waste of time, like this thing, the one on the way at the top. Bond line is definitely better. Once you get a hang of it, you save a lot of time. So we see that we have 7 carbons on our longest carbon chain, and we're going to associate that with heptane. Heptane is the alkane for 7 carbons, so that's going to be our ending. Now remember, we need to have something to put in the beginning. We're going to have a number, then we're going to have a branch, and then we're going to have our parent. And we know already, this is essentially how the name is put together. We know that our parent right now is going to be heptane. So I'll fill that in on blue to give you a different color. Now we need to know what number is our branch appearing on. Now we're only dealing with one branch right now, and you saw last video how we deal with many branches. We see our branch is on carbon number 4. And obviously there will be a hyphen between this. I'm just putting a plus sign just to show you guys, and I'll write the full name out after. Now we need to see what our branch is or what our alkyl group is. They're essentially the same thing. So now you want to look. You see 1, 2, 3 carbons. Like we said, that alone, if you just disregarded this whole thing and you just cut this right here and took this by itself, it would be propane. So you want to cut off that ane ending and replace it with propyl. And that's exactly what our branch is. And our final name would be for hyphen, always a hyphen between the numbers and the names, for propyl heptane. And simple as that, we broke down this complicated structure into just using a little very simple steps. It's just a process. If you memorize the steps to the process, you'll have an easy time doing it. Now, a little thing and one last little detail you want to take into consideration when you're numbering your branches. So let's look at our branch right now. Let's have 4 carbons. This would be a butyl group. Some books will just leave it open like this, and this end here is going to be attaching to your compound. Some books might put an R there. The book I use puts an R. R just means the rest of the structure. So if you see this, this here, in the case of what we had up here, all this here would be R. Sorry, a bit of lag there. All that there up there would be R. So R just means the rest of the compound, and this here would be your alkyl group. In this case, butyl. It's butane without the A and E. So what you want to do numbering wise, the only thing you just want to know when you're numbering, you're going to want to number from the point of attachment, no exceptions. So no matter what happens here, you're really going to want to number from this. So always associate the first thing that's attached to the rest of the compound with number 1, and then go on from there. So you might have some substituents on it later on, so you might get something more complicated. Like say you have this alkyl group right here. You have your rest of the compound right here. Then you have, say, CH2, CH2, CH, CH3, and then another CH3 attached. So let me just, there. It's not a double bond, just ignore that. So you see how we have 2 methyl groups right here. We have a methyl branch going on right here. You might be tempted to say, oh, okay, I want to associate the lowest number to it, a number like this. You're not allowed to do that. When numbering specifically alkyl groups where you have this point of attachment, you're going to want to number from the point of attachment, no exceptions. So no matter what happens, the number 3 needs to be associated with that methyl group. You cannot associate the number 2 because you'll be numbering it in the wrong direction. So just another rule to take into consideration. The IUPAC, IUPAC, no matter, everybody I've met pronounces it differently. There's a lot of different rules you're going to know when we get into alcohols. All the knowledge you think you know already will change again. So it's pretty much organic chemistry for you. It's very important that you separate these different tools that you're going to learn over the next time, just so you don't get stuff confused. So So that's alkyl groups right there. It's essentially an alkane, but you're going to drop the ending, and you're going to drop, you're dropping one hydrogen because you have that point of attachment instead of a hydrogen. So you cannot have the 3 anymore. You need to turn the 3 into the 2. And that's, that just becomes common once you see that you already have 2 bonds attached to your carbon. You're automatically going to associate 2 more hydrogens to fill up the 4 bond or the octet, or however you want to look at it.